Hi everyone, this is your spring semester 2021 final exam review. So we're going to get started. I might cut this in a couple of pieces just depending on how long it goes. So let's get started. All right, so number one just says factor each. So when I see this, it looks like I can just do some grouping here on this. So I'm going to put these in a group and I'm going to group this part. So now I can go ahead and in the first section I see that I have a common x squared in both of those. So that is going to be, I'm going to factor out an x squared, leaving me with x plus 4. And then in this section I'm going to factor out a negative 4. So that's going to be negative 4, and that will leave me with x plus 4 also. And that equals 0. So now I see two terms with a common x plus 4, so I'm going to factor out the x plus 4, and that leaves me with x squared minus 4. Alright, the x plus 4 is factored as much as it can, but the x squared minus 4 can actually be factored more because that's the difference of two perfect squares to be x plus 2 and x minus 2. So it looks like our final answer is x plus 4, x plus 2, x minus 2, so final answer is A. For number 2, I noticed that I only have 3 terms here, and fortunately my x to the 4th and x squared is going to work just like a quadratic. So I'm going to just say, alright, I need to find two numbers that multiply together to get negative 28, add together to get 3. And I know that that is going to be 7 and 4. How about positive 7 and negative 4? And that will get me the numbers that I need. So that's going to equal x squared plus 7 times x squared minus 4. Alright, so be really careful when you have a 4 and a 2 here that it's actually x squared. Alright, the x squared plus 7 is as far as I can go, and I have A, B, and C both have x squared plus 7, but D is x squared plus 5, so I'm going to go ahead and eliminate that. And then this is going to be the difference of two perfect squares again, x plus 2 and x minus 2. Well, this one is not it, and that one definitely isn't it, so our answer has to be B. Number 3, find all the roots. Alright, again, we're going to want to factor first, and I'm going to take a look at this, and I'm going to go ahead and group these two together. Let me change colors here. I'm going to put these two together plus the opposite. So I'm going to end up with, I see that I have a common x squared in that, so I'm going to factor out x squared. That's going to leave me with 3x plus 2. Plus, in here I can factor out a negative 3, and that will leave me with 3x plus 2 also. And here I have two terms that have a common 3x plus 2. So I'm going to factor out the 3x plus 2, and that leaves me with x squared minus 3. Alright, let's just take a look at these. If they equal 0, 3x plus 2 has to equal 0, or x squared minus 3 has to equal 0. So subtract 2 from both sides. We have 3x has to equal negative 2. Divide both sides by 3. So x has to equal negative 2 over 3. So I'm just going to go ahead and look at my answers first. And there's only one I see that has an x equals negative 2 over 3. So number 3, I don't have to do any more work. It's just equal to C. Alright, number 4. Again, same thing. I'm going to go ahead and factor out. And it looks like I can factor out an x squared. and that's going to leave me with 2x minus 5. And then over here, it looks like I can factor out a 4, which also leaves me with 2x minus 5 equals 0. I have two terms that have a common 2x minus 5, so I'll factor that out, leaving me with x squared plus 4. And that all equals 0, so either 2x minus 5 has to equal 0, or x squared plus 4 has to equal 0. Alright, well, let's go ahead and do this first one. 2x has to equal positive 5, so x equals 5 over 2. So let's go ahead and check and see what I have there. I'm looking for a 5 over 2. Well, that one didn't have a 5 over 2, and nor does that one. So I only have two choices left, so let's go ahead and keep moving. Let's subtract 4 from both sides. End up with x squared equals square root of x squared equals negative 4. Take the square root of both sides. So x is going to equal 2i. Alright, well, this one is not it, so I've only got one choice, and that's D. Number 5, describe the end behavior. Alright, let's remember what end behavior is. So this one is going to be negative cube. Alright, so I always sketch out what is that going to look like. If you don't remember all of these, you're going to need to get these memorized because you won't have any extra help on your test. Okay, so here is what the negative cube looks like. Alright, so now I'm just going to start, and the way this program sets this up, f of x, remember, is y, and we have always said as x approaches something, what happens to y? So I always read this a little bit backwards. So here it says as x approaches negative infinity, that means as x goes this way, y is getting positive. And here it says as x approaches negative infinity, y is getting negative. So I'm going to cross out A. Alright, let's try B. It says as x approaches negative infinity, y gets positive, so that's true. And then let's try the next one. As x approaches positive infinity, y gets positive. No, our y is getting more negative, so it can't be B. Alright, let's try C. As x approaches, let me redo that. Alright, as x approaches negative infinity, y approaches positive infinity. That's true. As x approaches positive infinity, y approaches negative infinity. So that's the one that's true. Alright, next we have, this is an odd positive. Okay, so odd positive is going to look like this. You'll need to make sure you remember all of these. Alright, so here we're going to start out as x approaches negative infinity, y approaches negative infinity. That's true. As x approaches positive infinity, y approaches negative infinity. Nope, that's not true. Alright, let's try the next one. Alright, as x approaches negative infinity, y approaches negative infinity. That's true. As x approaches positive infinity, y approaches positive infinity. That's true. So there's your final answer, B, for number 6. Alright, number 7. This is an even exponent and it's positive. So that's just a parabola that we've seen and used many, many times. So we'll just draw what that looks like, a sketch. Alright, here we go. As x approaches negative infinity, y approaches negative infinity. Not true. Alright, let's try the next one. As x approaches negative infinity, y approaches negative infinity. Still not true. Alright, letter C. As x approaches negative infinity, y approaches positive infinity. That's true. As x approaches positive infinity, y approaches positive infinity. That is true, and that's our final answer. Number 8. Okay, Here we go. This is even, exponent, odd, lead coefficient. So that is going to be our upside down or frowny face parabola. And here we go. As x approaches negative infinity, y approaches positive infinity. Not true. So we'll cut that one out. All right, B. As x approaches negative infinity, y approaches positive infinity. Still not true. C. As x approaches negative infinity, y approaches negative infinity. That's part true. As x approaches positive infinity, y approaches negative infinity. That one is the true one. All right. Number 9. Rewrite each equation in exponential form. Okay? Let's see, what color did I do? Red. Orange. Okay. So let's go with this one. Remember, the log is equal to the exponent. All right? The log is equal to the exponent. So we can do our little scorpion here. 9 raised to the 1 power equals 9. Okay? 9 raised to the 1 power equals 9. And so that one's pretty easy. That's going to be A. All right? I don't know how to make it any easier than that. Just do your scorpion and you've got it made. 9 raised to the 1 power equals 9. Okay? Number 10, 19 raised to the 2 power equals 361. Okay? 19 raised to the 2nd power equals 361. And that is letter D. All right? There we go. All right. Rewrite each in logarithmic form. Remember, the exponent is equal to the log. So here's our exponent, n. There's only one, actually, that has it. And we could check it. 13 raised to the n power equals m, and that's correct. So the answer is A. All right. Number 12. Remember, the exponent is equal to the log. The exponent is equal to the log, so we're looking for 1/2. Well, that's not 1/2, and that's not 1/2, so I've only got 1 over here, so I'm going to just go ahead and use my scorpion this way. It's going to be 225 raised to the 1/2 power equals 1/15th, and that one happens to be the correct one, so that's, let's get that right. C is for number 12. All right. Number 13. Evaluate. All right, so on this kind, we're just going to go ahead and set it equal to x. So we're going to have 3 to the x power equals 27. Well, let's just start working it out. 3 to the 0 power equals 1. 3 to the 1 power equals 3. 3 squared equals 9. 3 cubed equals 3 times 3 times 3, which is equal to 27. So 3x is equal to 3, so my answer is B. Number 14. All right, again, set it equal to x. 3 to what power equals 243. So 3 to the x power equals 243. Now I want you to just kind of look at the answers here. We already know 3 to the 3rd power is equal to 27, so it's not that one. 3 to the negative 4 power, that would be 1 over, because that negative sign means take reciprocal, 1 over 3 to the 4th power, which would equal, that doesn't look like the 4th power, 1 over 81, so it can't be negative. Let's look at 81. 3 to the 81 power, that would be 3 times 3 times 3 times 3, blah, 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 blah. That's way more than 243, so that can't be it. So it has to be B, but we'll just work it out. 3 times 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. That's 81 times 3. 3 times, that's 243. So it's obviously B is your final answer. So sometimes you could just look at these and reason out what the correct answer is going to be. Number 15. says solve each equation. Well, let's notice something. Log base 3 and log base 3. So these two terms just have to be equal to each other in order for this whole thing to be equal, since they both have the same log. So all we have to do is say 3v plus 4 equals negative 4v. Let's add 4v to both sides. So we end up with 7v equals, let's say 7v plus 4 equals 0. So let's subtract 4 from both sides. We end up with 7v equals negative 4. So v equals negative 4 over 7. Alright, and I only have one, negative 4 over 7, which is C. So 15, the answer is C. 16. Again, I have the same base, log base 19, so that tells me that 4b must be equal to 2b plus 10. So let's solve by subtracting 2b from both sides. That leaves me with 2b equals 10. Divide both sides by 2, so b equals 5. So it must be B. All right. Number 17. It says solve for each and state the excluded values. So we need to simplify and then state the excluded values. So let's, what I think is really easiest is do the excluded values first and then just see if anything happens there. So let's look at this. I know that 5x minus 45 cannot equal 0 because I cannot have a 0 in my denominator. Alright, so let's go ahead and solve for x and find out what x cannot be equal to. So I'm going to say 5x cannot be equal to, I'm going to add 45 to both sides. Divide both sides by 5. So x cannot equal 9. And so if I just look at my answers here for 17, I see that there's only one choice where x cannot equal 9, which is B. So I'm actually done right there. I don't even have to do any of the simplifying on there. However, I am going to go ahead and do the simplifying. Let's look at this. I'm going to say two numbers that multiply together to get 9, add together to get negative 10. Well, that's going to be negative 9 times negative 1. So that is going to equal x minus 9 over x minus 1. All right? And then 5x minus 45, I can factor 5 out. That's going to leave me with x minus 9. My x minus 9's cancel out, which leaves me with x minus 1 over 5, which we said was our answer, and x cannot equal 9. So always check just your excluded values first, and if you do that, then you probably can get your answer, but if not, then you'll need to simplify it a little bit more. But usually you can at least eliminate one answer. So let's check and see if that works on this next one. I haven't done all of these, so we'll see if that works. Okay, so on this one, I'm going to check my excluded values first. Actually, when I look at this is just equal to 1. M squared plus 5m plus 4 equals m divided by the same thing, so it's going to have to just equal 1. So for 18, my solution is 1. And let's just check. It's the only one that has a 1, so it has to be B. But let's go ahead and factor that. Two numbers that multiply together to get 4, add together to get 5. That is going to be 4 and 1. So we have x plus 4 times x plus 1 in the denominator, the numerator, and we have x plus 4, x plus 1 in the denominator, so they would all cancel out. But to find your excluded values, we need to remember that x plus 4 cannot equal 0 and x plus 1 cannot equal 0. So x cannot equal negative 4 and x cannot equal negative 1, which is our answer for B. So 18 is your answer on that one. All right, number 19. Again, let's check your excluded values first. So I'm going to look in my denominator. X squared minus 49 cannot equal 0. So x squared cannot equal 49. So x cannot equal plus or minus 7. So when I look at all my answers, there's really only one number that has that, and that's letter A. And so that's got to be my final answer. I don't really even need to go any further on that. Let's go ahead and factor it all out just to make sure. So 7x plus 49, I see I have a 7 in there that I can factor out. That leaves me with x plus 7. And in the denominator, that's the difference of two perfect squares. So it's x plus 7 times x minus 7. Again, I can clearly see that I can't have x be plus or minus 7. And these will cancel out, leaving me with 7 divided by x minus 7, which is what letter A is. 20. All right, let's go ahead and check our excluded values first. So let's just say I've got 10a squared plus 60a, and that cannot equal 0. I can see that I have a common 10a in both terms, so that's going to leave me with a plus 6 cannot equal 0. And so 10a cannot equal 0, and a plus 6 cannot equal 0. So here, divide everything by 10. So a cannot equal 0, and a cannot equal negative 6. And there's only one. There's a couple that have a cannot be 0, so that's not it and that's not it. But this one is our final answer, C, because it has both of them in there. In the event that you do have to factor everything, let's take a look at this. Two numbers that multiply together to get negative 12, add together to get 4. That would be 6 times negative 2, so we'd have x plus 6, x minus 2 in the numerator. In the denominator, again, I'm going to cancel out 10a, and that will leave me with x plus 6. So our x plus 6's cancel out, leaving me with a minus 2 over 10a, which again is your answer for 20C. All right, 21. Solve each equation, and remember to check for extraneous solutions. Okay, so let's check for our extraneous solutions first. So here I see that b cannot equal negative 4. Otherwise, it would be 0 there. And here, b cannot equal 0. Otherwise, it will be wrong here. And then this one, b squared plus 4b. You can see I can factor out a b. That would leave me with b plus 4. And we don't want either of those, any of that to equal 0. So here we have, again, b cannot equal 0 and b cannot equal negative 4. So there's my extraneous solutions. And notice that this one has a negative 4 and this one has a negative 4, which it can't be. So I can automatically eliminate b and d without doing anything. So even if you get stuck or something, you can at least eliminate 2, and now you have a 50-50 chance of getting it. So let's go ahead and solve this. So first of all, I see that I've got adding and subtracting, and I've got all these variables in my denominator, which I don't want to get. I don't want to have. So what I'm going to do here is I'm going to find a common denominator and then multiply everything by that. So I have a b plus 4. I have a b, and let's factor this out again. That's b plus 4. Okay, so I can see that my common denominator is actually going to be b times b plus 4. So I'm going to multiply every piece times b plus 4. b times b plus 4 and b times b plus 4. All right, so in this one, I have a b plus 4 and a b plus 4 that cancels out, and so that just leaves me with 1 times b, which is b, equals. Here I have a b and a b that cancel out, and that's going to just leave me with 1 times b plus 4. So equals b plus 4. And then I'm going to minus, okay, and this is all the way cancels out. So I'm going to subtract. Now I have to be careful. I'm subtracting that whole packet, b plus 2. All right. So I'm going to distribute this distribution, and I'm going to change that and that. So what I have is b equals b minus b. Those cancel out, so that's it, nothing. And 4 plus negative 2 is positive 2. So b must equal positive 2. So your answer for number 21 must be C. It's the only one. All right, let's try this one again. All right, this one, not so lucky. We don't have any thing that we can automatically eliminate, because 2v, v cannot equal 0, but I don't have any that have 0 in there. So again, I need to have a common denominator, and it's easy on this one. It's going to be 2v, so I'm going to multiply everything by 2v and 2v. All right, my 2v's cancel there, 2v's cancel there, so I'm left with 2v equals 1 plus v plus 4. All right, so 2v equals v plus 5. Subtract v from both sides. That leaves me with v. 1v is equal to 5. So for number 22, the answer is A. 23. We've got to simplify. Now I always simplify my variable first to see if that's going to help me. So notice my index is 4, and I have 4 v's. 1, 2, 3, 4. So I can circle all of those, so my answer can't have any v's in it and has 1 v taken out. So let's see if that helps me at all. So this one has a v still in there, so I know it can't be C. And the rest of them are okay. Now let's see, this one has 2 v's taken out, but I only could take out 1 v, so I'm going to go ahead and eliminate that one. All right, so now I have 2 choices, and 48 is made up of, let's take a look at 48. That's made up of 12 times 4. 12 times 4 is 3 times 4, which is 2 times 2. And that's 12 times 4 is another 2 times 2. So I've got 4 2's that I can take out. So both of them have that. And I'm left with a 3, not a 4. So my final answer for 23 has to be A. All right, let's look at 24. I've got 3, but notice I only have 2 m's. So my m's are going to have to stay in there. M squared has to stay in there as it is. So it can't be C. And let's see that. What happened to my square there? It can't be that one. And this one doesn't have my square in there either, so it obviously can't be that one. So the answer, without really doing a whole lot of work at all, I can see is going to be A. Now, if I want to go ahead and check on the 24, 24 is made up of, again, 12 times 2 this time. So 12 is 3 times 4, which is 2 times 2, and times 2. So I have one group of 3 2's that I can take out, and that leaves me with 3 inside. So there it is. Your answer is A for 24. All right, 25. Let's take a look at this. Here, remember, for exponents, we add our, if they're multiplied together, we add our exponents. So let's start out, and I'm going to see I have a 2 times 4. Those are just regular multiplication, is 8. Well, look at this. I only have one that has an 8, so I really don't even have to know my rules because that's the only one it could possibly be. But let's go ahead and figure out this rules anyway. I have a y to the first power and a y to the 5/3 power, so I have to add my exponents. So that's going to be 1 is the same as 3 over 3 plus 5 over 3 is 8 over 3, which is right, raised to the 8 over 3. Again, it's the only one like that. And then there's only one x, so that's 2/3, and that's right there. So for 25, your answer is B. All right, 26. Let's start out and multiply our coefficients together. 3 times 3 is 9. Well, looks like A is the only one that has a 9 in it. Let's go ahead and solve it just to make sure. N to the 1 power times 2 more n's is n to the 3rd power. That works out. And m, I have a 1/4 plus to the 1st power, which is 4/4. So that equals 5/4. So A is your only answer. 27. All right. Solve each equation and remember to check for extraneous solutions. So let's go for it. Okay. So I have, I need to get rid of that radical sign, so I'm going to take the square of both of those. So I end up with p squared equals -40 plus 13p. All right, well, this looks like a quadratic equation, so I'm going to go ahead and set it up like a quadratic. So I have p squared equals -13p. Let's not say equals, let's move our 13 over. Minus 13p plus 40. All right, well, let's factor that out. Two numbers that multiply together to get 40, add together to get -13. I think that's going to be -8 times -5. So that's going to be p minus 8 times p minus 5 equals 0. So that means p has to either equal 8 or p has to equal 5. All right, and since they gave me both 8 and 5, and they don't really give me any other choices, I can automatically just eliminate everything and see that the answer for 27 is B, because they're already there. I don't really need to worry about the extraneous solutions, because now if you wanted to, you could go back in there and solve each of them, but we don't need to. All right, same thing on the next one. We're going to take the square of both of these. That will leave me with 80 minus p equals p over 7. Okay, so I'm going to multiply both sides by 7. Okay, 7 times 8 is 560 minus p equals p. So we're going to add plus, let's see, did I do that right? I think so. Plus p and plus p. So I have 560 equals 2p. Hold on, what did I do wrong on that? Divide both sides by 2. What am I doing wrong? Let's see. All right, let's try this again. All right. We're going to take the square of both of these, and that would be 80 minus p equals p over 7. Multiply both sides by 7. Oh, here it is. Got to distribute that. So that is going to be 7 times 8 is 560 minus 7p. There we go. Equals p. So we're going to add 7p to both sides. 7p. That's going to give me 560 equals 8p. We're going to divide both sides by 8. And I see that p is going to equal 70. That looks better. All right, so 28 is 70. There's only one choice, so it has to be C. So there you go. 29. All right, this is find h plus g of x. So I'm going to say h of x plus g of x. All right, so h of x is 4x. And g of x is x cubed minus 5x squared. So I'm just going to put it in standard form. X to the 3rd minus 5x squared plus 4x. And it looks like that is number A, or letter A. And that's your final answer. All right. This one says g of h of t, and so what I have to do is rewrite it, g of h of t. So what is h of t? Well, h of t is, that's going to say g of t squared minus 1, just substituted. So now I'm going to take my g and everything that's in x, or in t in this case, I'm going to just replace it with that. So I have 4 times t, and in place of t, I'm going to put t squared minus 1, and then plus 2. All right, I'm going to go ahead and distribute my 4 to both pieces. 4t squared minus 4 plus 2. So 4t squared minus 2. And there's only one place where that is true, and that's letter C, number 30. All right, 31. Find the inverse of each. Okay, remember, f of x is the same as y. So y equals 9 over 5x plus 7 over 5. So to find the inverse, we switch our x and y's and solve for y. So it's going to be x equals 9 over 5y plus 7 over 5. So I'm going to subtract 7 over 5 from both sides. End up with x minus 7 over 5 equals 9 over 5y. So be careful right here. We're going to multiply by our reciprocal, 5 over 9 on both sides. 5 over 9. So these cancel out, leaving me with y. And so I'm left with 5 over 9x minus 7 over 5 times 5 over 9. My 5's cancel out, so I'm left with 5 over 9x minus 7 over 9 equals y. And that looks like it is letter D. Okay. 32. Again, we're finding the inverse, so I'm going to write it first as y equals x plus 2 squared plus 3. So I'm going to switch my x and y's and solve for y. X equals y plus 2. Oh, that's not to squared, that's to the 5th. Plus 3. All right, so subtract 3 first. So I have x minus 3 equal to y plus 2 to the 5th power. All right, remember we got to solve for y, so I'm going to take the 5th root, put my 5 up there, of both of these. So that's going to leave me with y plus 2 equals the 5th root of x minus 3. So I'm going to subtract, and that's a plus or minus. So I'm going to subtract 2 from both sides. So I end up with negative 2 plus or minus square 5th root of x minus 3. So here's my answer. Let's just take a look at these. There's really only one that has a 5th root, and it's this one. And the 2 is just in a different place, but it's still perfectly fine there. So my answer for 32 has to be B. 33, getting there. All right. So this one tells us to find all these things: the focus, the index, the focus, the vertex, the axis of symmetry, and the directrix. So, and also to sketch. But fortunately, since this is a multiple guess test, we have a little bit of an advantage here. So let's first of all find our vertex. That's always the easy. Well, two things we want to take a look at. First of all, I can see that this is y and the x squared, so this is a parabola, all right, and it's got a negative sign there, so I know it's going to be a frowny face parabola. So the first thing I'm going to do is check and see if I can eliminate some things, and I easily can eliminate this one because that's happy face. This one's happy face, so I only have 2 that I'm going to have to worry about. The next thing I'm going to do is look at my vertex. So I see that when x is negative 4, that would make this whole thing 0. When that's x is negative 4, y is negative 3. All right? So I'm going to look for a vertex at negative 4, negative 3. and I only have to look at A and D. And D, the vertex is at -4, -3. So I really don't even have to go any further than that. I can automatically see that 33 is D. Let's see. It's really all that we need to do at this point. Don't even try and axis of symmetry. You could look at that and see, take a look at those. But once you have the vertex, everything else is going to fall into place. All right, 34. We're going to use this information from the graph to figure out which equation of the parabola it is. Well, first of all, I'm going to notice that it's going in opening to the left. And so I know that's actually going to be the x equals y squared type. And so I'm going to go ahead and I can eliminate C because that's y equals. Now the next thing I need to know is it's going to the left, so this is actually going to be a negative sign here. So I can eliminate A also. So now even if I just guess, I still have a 50-50 chance of guessing correct. All right, now let's find our center, or my vertex. The vertex is at over -3 down -2. Okay, so there's my vertex. So my x is going to need to say x plus 3, all right, and my y is going to be y plus 2 because they're both horrible now, all right. And so it looks like we've got this situation right here. If I add my 3 to both sides, then I end up with that x plus 3 equals -2 y plus 2 squared. Got my y plus 2, I've got my x plus 3 in here, so my answer is D. All right, it's the final answer for 34. All right, it's a good one to learn. 35, we're almost done here. All right, identify the center and radius of each. So remember, if this, and just looking at this, I can see that it's a circle. So by looking at that, I know that this is radius squared. So the radius squared equals 4. So take the square root of both sides, so I can say the radius equals 2. Well, this one is wrong because that says radius equals 4. And this one is wrong because it also says radius equals 4. So make sure you understand the difference between those. Because notice they gave me 4. I could have just said it equals 4, but be careful, it's radius equals 2. All right, so now I need to find the center. So in the x direction, I'm going to go 13. In the y direction, I'm going to go 15. So this one's totally wrong. It's got a 14 in there. So it has to be C for 35. All right, 36. Again, we're going to use the information provided and write the standard equation of a circle. So when I find the center of my circle, right here, I see that the radius is 1, 2, 3. So radius equals 3, but this is radius squared in my formula. So radius squared would equal 9. So I'm going to eliminate these two because they don't fit into my formula correctly. Now I just have to find my center. So I went over -4 and down -3. So it's going to be x plus 4 and an x plus 3, which is D for number 36. Number 37 says identify all these things, okay, and sketch. So first of all, let's just take a look at this. I can see it's added, so it's going to be an ellipse, and all 4 of them are an ellipse, so that's good. All right, let's get our center. Center is going to be at 2, 2. So that's positive and positive 2. So notice this one is -2 and 2, so that one can't work. It could be B, that one could work. Can't be C because the center's in the wrong place. And it can be D. So now I need to check and see, is it D or B? I have a 50-50 chance. So in the x direction, I'm going to go square root of 25, which is 5. So let's start here. I'm going 1, 2, 3, 4, 5. That works. And look at this. In the X direction, let's see. Oh, that was 2, 2. And wait a minute. Let's go back. Where did it go? Let's see. Let's see. 2, 2. Okay. Oh, I did this one wrong. Starting at 2, 2, which is right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it could be that one. But look at this one. In the X direction, starting here, 1, 2, 3, 4, 5. No, it can't be there, so it can't be D. So it has to be B. All right, so just using some elimination, you can get these answers pretty easily. All right, again, we have an ellipse here, so we want to make sure all of these choices are true, and they are. The next thing we want to do is let's find our center. And our center is actually at over 0, up 1. So in the X direction, I'm going to need to have an X squared. So it can't be this one, and it can't be this one. Now up 1 would be Y minus 1, which has got to be that one, so it can't be this one. So it has to be D. Let's just go ahead and check and make sure. In the X direction, are we going 2, 1, 2, 1, 2? Yes. In the Y direction, are we going 4? 1, 2, 3, 4. Yep, 1, 2, 3, 4. So it has to be D for number 38. All right, 39 says, again, we have to identify all this stuff, but let's see what we can eliminate first. I can see that this is a hyperbola, all right, because of the minus, and it's going to be in the X, it's going to be opening horizontally because I have an X in that first position there. Okay, so I'm going to go ahead and eliminate the ones that don't have that on there. So this one is opening in the Y direction, so it can't be that way, and so is this one, so it can't be that way. So I have 2 opening in the X direction. Now my center point is at 0, 0. That's pretty easy. This one is at 0, 0. They're both at 0, 0. So let's take a look. In the X direction, I'm going to go square root of 1, which is 1. So I'm going to go here and here. And on the other one, look, I went all the way out to 3 on C. So it can't possibly be C. Let's just check one more time. In the Y direction, I'm going to go 3. 1, 2, 3. Yep, that works. And in the Y direction here, I only went 1, so it can't be C. So my answer for 39 has to be A. Oh, sorry, not A, B. I'd already eliminated A. All right, number 40. Got another hyperbola here. I see that it's a hyperbola because of that minus. The first term is Y. So that tells me it's going to look like this. So I'm going to eliminate anything that doesn't look like that. So this one isn't it, and D is not it. We automatically know those are not it. Okay, let's take a look at where our vertex is. Well, let's look at our center point first and see if that helps us at all. My center point is going to be careful with your X and Y's, at 2, 2. All right, so I'm going to look to see that everything's at 2, 2. And B is at 2, 2. That's correct. And C is also at 2, 2. So that's correct. So let's take a look at the next thing. Let's look in the Y direction. I'm going to go 3. All right. So 1, 2, 3. That works. 1, 2, 3. Okay. So B is still working. C, 1, 2, 3. Nope, that doesn't work. So it can't be C. So it has to be B. So for number 40 is B. 41. All right, we got another hyperbola. I can tell that by looking at the minus sign there. It starts with a Y, so I know my graphs are going to go like that. So A and B are potentials. C is a potential. D is a potential. Oh, I can't eliminate any of those. So let's take a look at the center. All right, my center is going to be at 2, negative 3. So I'm going to just try and find over 2, down 3. Okay, A could work. Over 2, down 3. B could work. Over 2, down 3. C could work, but D does not, so I can eliminate D already. All right, so now let's take a look in the Y position and the X position. I could go 2 and 2. So 1, 2, 1, 2. So I'm thinking it's going to be A, but let's just check everything else. This one goes 1 and 2, so it can't be B. And this one is 1 and 1, so it can't be C, so it has to be A. So 41 is A. 42, these are so easy now. All right, so classify. Well, I'm not sure, but I'll just divide everything by 9. And there's nothing else that can be eliminated, so this has to be a circle, 42, A. This one, in the X direction, I'm going to go 2, and in the Y direction, I'm going to go 6. So that has to be an ellipse. So that's C. This one is a minus, so it has to be hyperbola, B. And for 45, this one, I've got one variable squared and the other one not, so that has to be a parabola, B. And that is the end of your review. I hope that you learned a lot, and I will see you in the answer. Give me a call if you have any questions.